I need to revisit or say something about the chemistry. Now, some persons keep saying that the subject is very difficult or challenging. Well, to me, it's one of the simplest subjects you have so far. So the only thing you need to do is you have to follow the instruction. Now, the first thing I taught you guys, or the first thing I did was I gave you guys to write out compounds that we have and how to write compounds. And from that assignment, you guys really did good. And I told you that for you to write your compound, what do we do for the compound now? We write compound using the following way. You write the cation first, followed by what you call the anion. Okay, this is exactly what I said that we're going to do for the compound, all compounds. If you are writing all compound or any compound you are writing, this is the way you're going to follow. So coming to that now, I gave you guys some ions. So some of the ions, like maybe something like potassium ion, something like sodium ion, something like calcium ion, and something like magnesium ion, and something like what aluminum ion, and so on. I may not be able to list all. So then I didn't include one of the ion. I may not be able to list all, but I might try to list all again to ask you guys to write it again. So the first thing I did was that when I gave you guys this ion, I gave you, okay. So the first thing I did was that I gave you this ion, and these ions are known as the cation. Now this cation, I also gave you what you call the anions, and the anions that I gave to you was I gave you something like a chloride ion. I gave you something like bromide ion, iodide ion, oxide ion. Then we have the nitride ion. Then I also gave you the I didn't give you the hydroxyl ion, but we have hydroxyl ion. We have a nitrate ion. Then we also have the carbonates. I didn't give you all. I just gave you a few for you guys to practice. This time around, I'm not going to do that assignment. And what I told you guys is that assuming I want to write these two, what will I do if I'm to write these two? This is if I combine these two now. Remember the rule of writing your compound or every compound. Now, when you have maybe you have chloride ion and you also have a potassium ion. Now, the first thing you're going to write is you write the cation first, followed by what the anion. So, which means you're going to rearrange this. You're going to rearrange this. So, this is going to be chloride. Potassium comes first before what now chloride ion. Now, the numbers you're going to write, you take the numbers on top. The numbers, not the charge. Leave their charge. Just take their number. This one has invisible one, and this one has invisible one. So the one here goes to the down here, and the one here goes to the down here. So this is going to give you what you call K1 CL1, which is the same thing as what KCl. We remove the one. You all got this. You were able to get this. So I'm just trying to refresh your memory. Now let me pick this ion for instance, because we also have this ion. This is a cation as well. So assuming you have this ion for instance, and you want to do this one, how will you do this one? This is going to be, this is ammonium ion. You write ammonium ion, maybe ammonium ion, and let's say this ammonium ion and this radical, because this is a cation. Sorry, this is an anion. But inside anions or inside cations or inside ions that we have, inside the ions that we have in chemistry, we also have what we call the radicals. Now we also have what we call the radicals. These radicals are those ions that they have, maybe they have a more than one element with a single charge. So this is a radical. This it has two it has two elements but with a single charge. It has two elements but with a single charge. So this is this is a radical. This is a radical. This is a radical. This is a radical because it has more than one element with a single charge. So this is a radical. So assuming you have this radical and okay, let's pick this. Okay, let's pick this one that I circled here now. And I'm asked to get the compound. I have it as CO32 minus. So what will I do now? I will take the number on top. I will leave the charge. I will leave the charge. Remember, you take the number on top, you leave the charge. So when you take this number here, you take it below. And when you take this number here, you take it below. So this is going to be what? Now I'm going to have it as NH4. Now, because this 2, I want to write it here. I'm not going to, if I write 2 here, it's going to be, it will look like 42. So to avoid that kind of look, please, you are going to put it in bracket because that 2 is for every every element that you have here. So this is going to be NH42. You write 2 here. Then because of this one, we'll come to this place. So I'll write CO3. It's supposed to be all brackets 1. But you know, 1 multiplying everything is going to be the same thing. So because it's going to be the same thing, I'll just write it out like this now. NH4, all bracket 2, CO3. That is, I'll write CO3. This is the way I'm going to stop it, CO3. This is going to be 3, like this, like below. So, like, I'm going to have it as NH4 brackets, all brackets, what? CO3. This is the proper way to write it. Please, this way I wrote it before wasn't correct. So this is the proper way to write it. Now, since you've already learned how to do that, you've learned how to do that now. Now, to tell you or to show you that chemistry are all interconnected, they are all the same thing, I told you that apart from this, that the next thing you are going to do for me is how to reverse this compound to its ion. That this compound now, how to reverse it to its ion. How to reverse this compound to its ion. So that's the next thing you're going to do for me. So which means that if I give you any compound, I expect you to dissociate it. I expect you to break it down into its ion. So how do you break them down into its ion? Be very careful whenever you're breaking them down. Because if you're able to learn how to break compound into its ion, it's going to help you in terms of when you want to solve questions
Master,
on the...
please, I don't understand.
Don't worry, I'm going to give you an example now. Don't interfere. I'll give you an example. I'm not done yet. So the essence of this on how to break this into its ion is that when you come to electrolysis, you hear about what you call dissociation. So let me give you an example of how I mean by and how to do that now. Now let's take for instance now, assuming I have this compound. Remember, assuming I have this compound, you remember how I did this compound. This is NH4 to CO3. Now, this compound, you remember how I was able to, I just combined it. I just did this now and I got this using ions and I got this compound. Now, assuming I don't know this compound and I want to reverse this compound into its ion, like I want to break them down, or yes, break them down into its ion. What will it look like now? Remember, the same rule apply. You've already known from what I'm saying now that every first compound, because normally you're supposed to identify the compounds, you have to identify the ions and the radicals. Before I start breaking it down now, there is one task I'm going to give to you people now. Now, the first task I'm going to give to you people before I proceed now is that you have to go to your chemistry under electrolysis, electrolysis. Give me all, you have to state all the electrochemical series that we have. In fact, electropositive, electropositive, electropositive. Let me use that because I know if I say you should go and give me all the anions and cations, you may not be able to find it. I'm not the same thing with you. So under your electrolysis, go and find all the electropositive and find all the electronegative, all the electronegative that we have, negative that we have. So that is going to help you for now. So what I'm going to tell you is this now. Assuming you have something like this now and you want to break them down into its ion, how will I break them down into its ion now? Now you've already known that this one now, NH for all bracket 2 is just 1. So this one is the cation. That you know the first one are always cation. First one is always cation. Then the second one is always what now? Anion. And most compound you are going to see in chemistry for your level, it's always binary. Please, when I say binary, I mean one thing. For your level now, most compound you are going to be seeing in chemistry is going to be binary. Binary in the sense that it will only have one cation and one what anion. I am not saying that it's not possible for you to see more than one cation. It is possible. In fact, when we start topic like salt and its compound, the various type of salt that we have, I'll mention to you that we have what you call the complex compound, and there are some double salt and the complex salt. So when I measure those salts, now these are the ones that they normally have more than one cation. They have more than one cation, but in general, all compound you see is always have one cation and what? One anion. So anytime I give you a compound, the first thing you need to do is, the first task you need to do is break them down into the two ions, the cation and the anion. Identify that the one that is the cation and identify the one that is anion. Now you are going to have one challenge. The challenge you are going to have is that most times at your level, you may not know the the radicals that we have, because if I say, if you whether you're going to know the anions and the cations, I will tell you how to know the anions and cations that we have. How to identify is very simple. I will tell you now. I'm going to tell how to identify the anions and cations. But the only problem you're going to have is this now. How can you know, or how can you know all the positive radicals that we have? Like the positive radicals that we have, that's the problem you're going to have now, or the challenge you're going to have. And how are you going to know the negative radicals that we have? Because the radicals are the only challenge you're going to have. The radicals are only going to be the challenge. And this question that I have here has to do with radical, like this one is a radical and this one is a radical, so that the radical is the only challenge. But before I end this class, I'll comment on this radical again. So the first thing you're going to do is, now, like I said before, now every compound you see in chemistry for your level always contain how many now? One cation and what you call one anion. Though there are some of them that can contain more than one cation, but for now it's only one cation and one anion. So it means that if I look at this compound, the first thing I need to do is, I have known that this is NH for all bracket 2 is 1. This is a cation. Then the remaining one, since I've identified this one as the cation, this remaining one is going to be under what you call what now? The anion. So the first thing I'm going to do is I'm going to split this in. How am I going to split it? I'll write the first one as NH4 and I'm going to write the second one as CO3. That's what I'm going to write. Now, before I put their charges, the next thing I'm going to do is I'll look at the numbers below here and I'm going to take those numbers below back upward. Like I'm going to take them upward. So since 2 is here, I'm going to take 2 to this point, to this place, to this area. And since I don't have any number here because this is CO3, this 3 is for this O alone, not for this C. So if you want to go for because if I want to go for CO3, it means that what they have in common is what? 1. Because it's only 1 times 3 that will give you 3, and it's only 1 times 1 will give you 1 here, not 3. So you know that this one generally has one thing in common, which is 1. So you take that one up here. So since you have known that now, what you're going to do is I said you're going to take this 2 up here. If you take it up here, it's going to be 2 minus. And if you take this invisible one here, it's going to be what now? Plus 1 or plus. So this is going to be plus and this is going to be what? 2 minus. This is how you're going to break it. Now the question is, why are we even stressing ourselves? Why do we even need all this thing I'm doing now? Well, you need it because you have done what you call, or you might have done what you call electrolysis. And when you come to electrolysis now, before you talk about factors affecting preferential discharge of ions, whether a concentration of the ion, position of the ion in the electrochemical series, and nature of the electrode, before you talk about them now, you need to know how to break this, because if you don't know how to do this thing now, you cannot write the half cell reaction, whether the oxidation half cell reaction or the reduction half cell reaction. You cannot write them. And I need you to understand this topic very well, because if you understand it very well, as soon as possible, we'll go over to electrolysis. And anything I say in electrolysis, you can grab it. So you can easily write it yourself. That's the essence of it now. Okay, that's the essence of me explaining this now. Now, before I go over to how to identify your ions, how to identify these your ions now. Now, let me give further another example. I have H2SO4. Look at this one. I have H2SO4. This H2SO4 contains only 2 things. What are the 2 things it contains? It contains what you call the anion and the cation. Sorry, the cation and the anion. Now, looking at this now, where do you think is going to be the cation now? Well, I know, like I said before, you guys are yet to identify the radicals. But at least let me just mention some of these negative radicals so that it's going to be easy for us now. Some of these negative radicals that we have is what we call Cn, known as the cyanide ion. Let me spell cyanide. We have what we call the cyanide ion. Now, some of them is what we call OH, which is hydroxyl ion. This is hydroxyl ion. Then we also have what they call the carbonate ion, carbonate, that is tri also carbonate for ion. This is carbonate ion, trioxo carbonate, carbonate for ion. This is trioxo carbonate for ion. Then we also have, I've mentioned this, that is for the negative. We also have what you call hydrogen trioxo carbonate for ion, hydrogen trioxo carbonate for ion, that is HCO3 or minus. So this one is called um hydrogen hydrogen trioxo carbonate for ion. That is for this one. I'm just listing out some of the radicals so that it will make my work easier or make our work easier, so that some of you will not get confused how I identify the one that is in anion or cation. Then aside that, now we also have what you call SO4 2 more and minus sulfate ion, tetraoxosulfate 6 ion. So we have what you call tetraoxosulfate 6 ion, 6 ion. This is tetraoxosulfate 6 ion. Then we also have what you call the sulfite ion, triazosulfate 4 ion. Sulfite, this is sulfite. So we also have what you call trioxo sulfate 4 ion. Don't worry, in terms of this IUPAC nomenclature, by the time we learn, we've learned how to combine ions to form a compound. I'm now explaining how to break compound into its ion. With time, we're still going to learn IUPAC nomenclature, how to name them. And if you learn how to name them, then we still need to talk about how to balance them in equation. When you have two or more of them, yes, we need to talk about them. I want us to use one knowledge that we have here now. From one knowledge that we are having now, currently, the knowledge we are having now, we are going to use it to do a lot of work. That's why I say that I love chemistry for one thing. Chemistry is like, they are all the same story they are telling. From one topic you enter to another topic, for one other topic you enter another topic, they are telling the same story. There is no different. It's just for you to understand it. If you understand one, automatically you are understanding all. You might be surprised that from combining this into form a compound, which is your first topic. From compound, we might treat electrolysis. From there, we are going to talk about IUPAC nomenclature. From IUPAC nomenclature, we say balancing of equation, a lot of things. Before you could know it, we've almost done all the things in chemistry. So when people tell me that chemistry is difficult, I keep wondering what's difficult in chemistry, where they tell the same story up and down. So let's proceed. Now, coming to this now, I've already mentioned this now. I've mentioned the radicals that we have. I've mentioned the cyanide ion, hydroxide ion, triazo carbonate 4 ion, hydrogen triazo carbonate 4 ion. Then I also mentioned the sulfur, that is tetraoxosulfate 6 ion. Then I also mentioned triazosulfate 4 ion. So that is it. Then we also have what we call the nitrite ion. The nitrite, which is NO3 minus. That is triazonitrate 5. So we have trioxo nitrate 5 ion. Somebody may be asking me, Master, how do you even know this number you're calling now? This triazonitrate 4, triazonitrate 5. When I come to IUPAC nomenclature, I will name it. I will also mention about it, how to know those of them that have variable oxidation state. That number is oxidation state. Don't worry, I'll explain about oxidation state, because from this topic we are doing, I think with time, we talk about what you call oxidation number, and that is oxidation number and oxidation state. That's oxidation state. So with time. So coming to this now, I think I've mentioned enough. I've mentioned enough. That is for the cation. Sorry, for the anion. For the anion. So the one I mentioned currently, just for the anion. This is just for the anion. That's what I mentioned. For cation, we don't have much. I think the only cation that we have is this one. This is the only cation that we have. Well, if we have any other thing, I will still state it later. So for now, I'm only remembering this one. So this is the one I can say for now. So since you've already known that now, from this now, you've known that from what I've written here now, H2SO4, automatically, from what I've seen already, you've known that SO4 is an anion. How did I know? I mentioned it here. It's an anion. Anion, though, is under radical. I'll also mention to you other anions that we have. But this SO4 is an anion, negative ion, and is a radical. So automatically this one is an anion, and this one automatically, since you've known that SO4 is an anion, this one is going to be what? A cation automatically. So how is it going to look like if I am going to write this into its ion, assuming I want to write it into its ion? Now we've already known that I have it as H2SO4. So assuming I want to write that, this is what we call an anion, and this one is going to be what we call what now? A cation. Now you have this now, it's going to be H, and we are going to have what we call SO4. Now remember that SO4 always adding SO, it always go with its 4. Now these two that we have here, these two, where would these two go now? These two will now go up. Remember that this two is for this person, like it's below here now. I'm going to take it up here. And if I take it up here, it's going to be 2 minus, because anion always have a negative charge, while a cations always have positive charge. Now, what do we have here in common for this SO4? SO4 has one thing in common. The only thing it has in common is what? Invisible 1, not 4. Remember, not 4. The 4 is for the oxygen alone. But SO4 are together. And the only thing S and O have together in common is what you call 1. Like it's going to be invisible 1. Because 1 times 4 will give you 4. And 1 times 1 here. 1 times 1 here will give you 1 that is for this S. Because oxygen is 4 and S is 1. So be careful. So the only thing that you say that SO4 have in common is what? 1 they have in common. So automatically I'll come to this place. I'll write plus. Like I'll take the 1 up to this one. Remember I took the 2 below here, up here as and called it 2 minus, and I'll take the 1 here, up here, and I'll call it what? Plus or plus 1. So this is how I broke down this my compound into its ion. So this one becomes my cation. This one becomes my cation, and this one becomes my what? Anion. And if you've got an idea of this now, automatically you can start writing the half cell reaction of anything. Or before I proceed that now, before I leave that now, let me mention something like that of water. Let me talk about water, because I know that some people might be saying, Master, since you've already explained this now, how will water look like? Some persons might just say, water now, break it down. Is it not H plus and O2 minus? No, please. Water is an exception to what I am saying currently. For water, if you want to write water, please, if you want to break water into its ion, remember we are breaking compound into its ion. The only thing you're going to do is just write hydrogen and what? Hydroxyl ion. Because water is combined or is cutting from what you call hydrogen ion and what? Hydroxyl ion or hydroxide ion. It is either you call it hydroxyl ion, or you call it hydroxide ion. Hydroxide what? Ion. So they're all the same thing. So please, for water, water is an exception to that rule. Water is very, very exceptional to that rule. Please just take note of that. So what I'm going to do later is I'm going to take my time. I'm going to look at all, because you guys wrote out the compound that we have. You guys really did well, most of you. But I'm going to still take my time to get more ions and give to you guys, so that you guys will practice more and give me all the compound. I would have asked you, I would have added, or let me not say I would have, let me add it. Let me add it. I think I'm going to add something like this to you guys. Um, that's the first thing I'm going to add before I continue. Now, before I talk about how to identify the cations and the anions now, these are the cations that we have. Let me show you some of the cations that we have. Anions, I may not be able to write anions or the anions properly, but let me just write the cations. This cation that I'm writing currently, you are expected to cram them or know them off heart. So we have, first one, we have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, iron, tin, tin, lead, lead, hydrogen, copper, copper, mercury, and mercury, silver, and gold. So this is plus, plus, 2 plus, 2 plus, 3 plus, 2 plus, 2 plus, 3 plus. This is a 2 plus, 4 plus, 4 plus, that is 4 plus. Now this is 2 plus, this is 4 plus, this is plus, this is 2 plus, this is plus, this is mercury 2 and mercury 1. We have a mercury 2, we have Hg plus, we have a plus, silver 1 and plus as well. Okay, these are the things that we have so far. All right. So these are the cations that I have. So the first task I'm going to give to you guys is that, do you see this cation that I have now with you guys now? I would like you to tell me the colors of this cation. Somebody may say, this master don't come again. Like they give person unnecessary stress. Well, it's part of learning. What's the color of this cation? And the color of every cation will determine the color of that compound or that salt. The color of every cation will now determine the color of that compound. Okay, let me just give you a hint. The color of potassium is white, like white. The color of the color of this potassium. I'm not saying potassium metal, oh. That is the color of this ion in a compound. Like this potassium ion in a compound is white, not the not potassium metal. The potassium metal is every white, but the color of this, whenever you have a potassium ion in a compound, that compound will be whitish in color. Whitish in color. This one white, this one white, this is white, this is white, this is white. Okay, let me just say automatically, I'm even tell you the answer safe. Oh, so what's the essence of the assignment now? Okay, let me just mention a few. So this is white, so this is white, and this is white, and this is white, this is also white. Now this is white, this is green, this is reddish brown, reddish brown. I'm done. I won't write again. I won't write others again. So which means that a salt that contains potassium, that is potassium chloride, what's the color of potassium chloride? So whenever you're writing your compound, you tell me the color of potassium chloride or the salt you're writing. What is the color of potassium chloride? Automatically, if know the color is what? White. So what is the color of calcium chloride? Calcium chloride, the color is what? White. Now what is the color of iron 2 chloride? Iron 2 chloride, or the color is what? Iron 2 chloride is what? Green. You will see it's green. And remember, the determinant, the what determine the color is because of the ion. That ion determine the color. So that's why I expect you to give me the colors of the following. This one is not a metal, but it's a cation. So, and you are not going to exclude this one. If you're writing anything, don't give me the color of this one. Yeah, try others, but exclude this one as well. So the essence of it is that somebody may be asking, why should we even start learning the color of this thing now? We don't need them. Yes, one of the topics I'm going to explain to you is what you call salt analysis. And during salt analysis, that is when I'll start mentioning these colors: white PPT, yellow PPT, green PPT. I'll start mentioning these colors. I will start mentioning this again. So that is why I would like you to have an idea of this before we come to that level. So we'll be joining that as soon as possible. So that is for the cation. So what I did now is that I used the cation and asked you the colors of these cations in a compound. The colors in compound, that is exactly what I explained now. So we've learned how to get the color of these cations in a compound. I didn't mention anions because anions are kind of they are not too useful now. So the next thing I'm going to talk about before I leave these aspects of topic is, let's talk about what you call how to identify the ions that we have, the ions that we're going to have now. So apart from what you call the anions, apart from the what you call the radicals, which I have mentioned now, you are supposed to know how to get each of these ions. Now we have cations. For the cations, for the anion, whether anion or cation, the first thing you need to do is you go over to your first your periodic table. You have what you call the group 1 element. We have what you call the group 2 element. We have what you call the group 3 element. Group 4. We have 5. We have a 6. We have a 7. We have a 8. Okay, so let's look at this now. From group 1, elements in group 1 to 3 are known as the metals. They are called the metals. Then from 5 to 7 are known as the non-metals. They are called the non-metals. You know that already. Then these ones are under the category of metalloids. They are non-metal and they are not non-metals. Now, the oxidation number oxidation number or the charges of element in group 1 is always what? Plus 1. So any element in group 1 will have a charge plus 1. Element in group 2 is going to have a charge of plus 2. Element in group 3 will have charge of plus 3 or 3 plus. Element in group 4 is going to be either plus 4 or minus 4. So that's why I'm going to exclude this. Then element in group 5 is going to be minus 3. Non-metals, it becomes minus. Element in group 6 minus 2. This is going to be minus 1. And this one is going to be what? 0. That is it. And the next thing I'm going to explain now before I continue is this now. How do you know the elements and their groups now? Call any element. Now let's mention any element. Okay, let's say for instance now we have something like sodium. I'll ask myself, sodium is in group what? It's in group 1, group 2. I don't know the group. So, but the first thing I need to remember is what is the atomic number of sodium? Atomic number of sodium is 11. And since atomic number of sodium is 11, I'm going to write this sodium in what we call the KLMN structure. And that KLMN structure says that the first shell is going to be 2, while others are going to be what? 8, 8, 8, 8, and so on. So it means that if I'm to write this sodium, now I'm going to write sodium here is going to be 2. 2, it's not yet up to 11. So I'll continue. I'll write 8. It's not yet up to 11 because 2 plus 8 is going to give me 10. Now what is going to remain? I remain 1. Now this is 11. Now this is 11. Because of this one, now this one belongs to what you call group 1. So automatically sodium, in terms of its ion will become sodium ion. Likewise, if you count this 1, 2, 3, this will also tell you the period it belongs to. You see, that's why that when you come to periodic table, that's why I said that chemistry are the same thing. They are all telling the same stories. So when we come to periodic table, we'll explain further on this now. Now let's look at element like oxygen. Let's look at oxygen. 8. For oxygen, I'm going to have it as what? Oxygen is going to be what now? 2 and 6. If I'm not mistaken, yes, this is 2 and 6. So which means that it belongs to what we call the group 6. And group 6 elements will have minus 2 as their charge. So that is why if you want to write oxygen ion, you write it as O2 minus. So you now see how to identify, how to write the charges, how to write the charges of what you call representative elements. Now these metals and the non-metals are the representative elements. Now the way we write this now is quite different from when you talk about quite different from what you call radicals. Remember, it's quite different from what you call the radicals. I've mentioned about the radicals. And also the transition metals, also the transitions. These ones are the headache that we have. So how to write the ions of radicals are quite different from, no, for transition they are the same, just that transition always have more than one charge. They always have more than one charge, but they're the same thing. So the ions that we have, the ions, before I continue with that now, the ions that we have, or if you want to get an ions now, it's represented in 4 ways. Let me mention that now. This ion that we're talking about, the ions we are talking about, generally ions that we have are categorized in 4 ways. That is one, from the metals, all metals. Now from the metals, now the metals I'm going to talk about is just, now let me explain this one now. Let me start from ions. I'm going to start with what we call the representative metals. Representative what? Metals. Ions that we have are gotten from the representative metals. Now these are the ones in the first 20 elements, 1 to 20. The ones, those metals within this range, 1 to 20. Now ions from 1 to 20, remember their charges now. For metals now, it's going to be from plus 1 to plus 3 or 3 plus. That's what it's going to be from. That is the charge they are going to have. Is going to be between 1 to 3. It's not going to be beyond that. It's not going to pass that. It's not going to be more than that. That is for representative metal. So any metals that fall within 1 to 20, we have this kind of charge. That's the first thing you need to take note of. And they don't have variable oxidation state. Like they only have one oxidation state, only one oxidation number. One oxidation number in the sense that sodium ion is sodium ion. We don't have sodium 1 ion. Calcium ion is calcium ion. We don't have calcium 2 ion. Magnesium is magnesium. We don't have magnesium 2 ion. So with these metals, I don't know whether you people are getting my explanation, because I want, before I mention other ones, the other forms that we have, I will still mention about other ions that we have. I want you to understand these representative metals. It just simply means that when you come to your periodic table, those ones you are going to see within the first 20 elements now that we have. I mentioned here to be 1, 2, 3, 4, 5, 6, 7, 8. So we have 1 to 3. So the one I'm talking about right now, this representative methods, which is from 1 plus 2 and plus 3. The one I'm calling representative metals are with the ones within this range, the ones within this range, the ones within this range. And these ones within this range, which is within the first 20 elements, they don't have variable oxidation state. Like the oxidation state is always the same thing. Like 1 is 1, 2 is 2, 3 is 3, 3 and so on. That is for this one. Now that is for the first ion. Now the second one is what you call the representative. I call them representative what you call sorry, representative non-metals. Non-metals. Now these ones now fall within the range of these ones are they are still within 1 to 22 of your first of your periodic table. But from which group now? They are from group 5 to 7 in your periodic table. In your periodic table. Now, these ones as well can have variable oxidation state. Yes, they can have more than one oxidation state. They can have more than that. When we come to IUPAC nomenclature, I'll mention about these ones. Just remind me of it that I should state the ones that have more than one oxidation number. There's one, I hate that element, it's very stubborn. One of the elements is nitrogen, very, very stubborn. It has charges, it has oxidation number from -3 to 0 to 1 to 2, 3, 4, 5. That's what we have nitrogen. We have dinitrogen 1, dinitrogen 2, nitrogen 3, nitrogen 4, and nitrogen 5 oxide. It has more than one. So that's why I say that we need to talk about it. Then another charge, another one under the ions are the transitions. Now these ones are the transition metals. Transitions. Ions from the transition metals. Ions from the transition metals. Normally, most of the ions from these transition metals, they are more than they exist in more than one. Most of them exist in more than one oxidation state. Please, these transition metals, you're going to find them from what do you call it? So from 21, they're always between there's one group, I think, between group 2 and group 3, but there is from 21 upward, and so on. That's when you get the transition metals. And the last group of ions that we're going to talk about is the radicals. Are the radicals. So for this chemistry of a thing, if we're doing anything about ion, ions are going to be coming from the metals, ions that is metals, coming from the non-metals, coming from the transition metals, and coming from the radicals. You have to know the ions from metals, ions from non-metals, how to write ions from transition metals, and how to write the ions from radicals. And the ones that have one oxidation state, which is the metals, the ones that have variable oxidation state, non-metals, the ones that also have variable oxidation state, which is transition metals, and the one that only have maybe they contain two or more elements with a single charge, which is the radicals. So this story is one thing we're going to tell you another day. I'm going to tell the story for this another day. It's going to take you a while during the process of IUPAC nomenclature, how to name compounds. That is when I'm going to mention this again. And during the process of mentioning that now, we have a lot of things to still learn as well. So this compound of a thing that I'm explaining, it leads to a lot of things, because on the process of learning this compound, because I've already talked about how to break from compound to ion. Now I've taught you how to combine, how to return it back to ion, like how to break compound to ion. Yes, I've taught you how to combine ions to compound. Then I've taught you how to break compound to its ion. Now we still need to come back to that compound again. We have a lot of things to learn on that compound. One of the things we're going to learn is we need to talk about solubility, stability to heat, and so on. So we are not going to rush them. It's gradually. Just bear it in mind that most of the things we do in chemistry has to do with compound. It has to do with this compound. Uh-oh. Okay, my time is up already. 15 minutes gone. Wow. So most of the things that we are going to do in chemistry is going to be based on compounds. So we have a lot of story to do on compounds. So if you understand compound in chemistry, trust me, there's nothing you won't have as a problem. You have nothing as a problem. So that's it. So I think I've explained a lot of things under this. So I think I'm going to allow you guys to ask your question. So what are your questions?
hydrogen abi na in H will go on top of SO4.
All
Den
right,
master, why is now like I don't know, you can't added charge on top of the H, how come?
let me explain again. Okay, turn off your mic, please. Please turn off your mic. Kosi, turn off your mic, please. Kosi, turn off your mic. Okay, so back to the question she asked. She said that she did not understand the magic that I did here. Well, I don't know whether she came in early, but let me just revisit this again. I first told you that the first thing you're going to do is you have to identify what you call the anions and you have to identify what you call the cations that we have here now. Now, I told you that the first, normally now, I told you that every compound for your level, every compound contains two things, and the two things they contain is what you call the cation and what you call the anion. One cation and one anion. I am not saying that it's a must. Some compound can contain more than one cation. We are going to see that, but they are not much. They are not much. So for your level, now this one is the cation and this one is the anion. I've already listed out this during my process of explanation. I've told you that SO4 is an anion, is a radical anion, but a radical. Sha. So we have this to be the anion. Okay, this is going to be the anion, and the other one is going to be what we call the cation. Now, the what I did was that since I've identified cation and your anion, please, I need you to do something for me. What I need you to do is these two in particular is only for this hydrogen. Be careful. I need to be very, very careful. This two is for this hydrogen. Now, for this anion now, this 4 is for this oxygen, but anion, since this is a radical, SO4 are together, so which is SO4 is 1. They are all together, like they are all together. So since it's that way, the only thing you need to take note of is that be careful that this 4 is for this oxygen, and this sulfur has 1. uh, Sulfur has 1 in it. So when you combine both of them together, what they have in common is 1. What they have in common, like 1 times 4 will give you 4, and 1 times 1 will give you 1. So what they have in common is 1. So since they have this as 1, now this 1 will go on top of this hydrogen. Whereas this 2 that is beside this hydrogen, since it's for this hydrogen, will now go on top of this person. So we're going to have hydrogen, we are going to have sulfate. Now the 2 below here will now go on top of here to be 2 minus, and the one here will go on top of this here to become what now? Will become plus. That's all I did. So that's how you got there. Remember, I've done how to reverse it. If you want to form a compound using this, now what you're going to do is you take down take these two below here, and take one here below here to get this compound. I just reversed it. That's the only thing I did. So there's nothing much here. So okay. Um in our today's physics class, we're going to continue from what we have as our dimension. Now somebody might be wondering, why are we even talking about dimension? Why are we even talking about dimension? Now, the essence of my class, or this class that I'm doing, I am not rushing you guys because we have multiple times. We still have little time before our examination. So let's take our time to understand all these things so that by the time you move into the hall, any question given to you under dimension, you will be able to solve it properly without any form of fear or challenge or guessing work. You can't guess, you just give them the answer straight to show them that you be better. You sabi and well. Okay, so now I've explained dimensions of Pascal of pressure. Now before then, remember that I always tell you that when you have unit like Pascal, which is for pressure, pressure is for Pascal, that is the unit. This Pascal has alternate units of Newton per meter squared, Newton per meter squared. I'm just giving a recap. The Newton per meter square, and also have what they call the basic units or basic SI units of kilogram per meter per second squared. Kilogram per meter per second squared. Now this is the unit, this is the alternate unit, and this is the basic unit. And we normally use the basic unit of any quantity. We normally use the basic unit of any quantity to get their dimension. Now, why do I call it a basic unit? Because this contains what we call basic unit. Kilogram is a basic unit, meter is a basic unit, and second is a basic unit. Remember that the basic unit that we have are kilogram for mass, that is kilogram for mass, meter, I'm just giving a recap, meter for length, and seconds for time. These are the basic unit that we have. Then we also have ampere, ampere for what? For current. Then we also have mole for amount of substance, amount for amount. We also have Kelvin for temperature, and so on. I can list them out, and so on. So anytime you have your unit and you look at this now, this thing does not, in fact, this one contain the basic unit, which is M. So I'm going to have this as capital M in terms of dimension, because I once told you that anything measured in M or any unit, whenever you see the unit kilogram, the dimension is going to be capital M. That whenever you see the unit meter, this is unit, this column is for units. Whenever you see the unit meter, the dimension is L. And whenever you see the unit second, the dimension is T. And whenever you see the unit ampere, the dimension is what? I. And for units of mole, the dimension is small n. And when you have the unit of Kelvin, the dimension is what? Theta. So that is how to get the unit of it. Just Okay, so I just mentioned that now, that these are the unit that we have. These are the unit that we have. We have the first unit that we have here is kilogram. This kilogram has a dimension of capital M, and this one has a dimension of what? L, because meter, for meter, I told you meter is capital L. I'll write raised to power minus 1, the charge that we have here. And this second has a dimension of what? Capital T or minus 2. So this is the dimension of what you call the dimension of pressure. This is for pressure. That was where we stopped last. We stopped at pressure last time that we had the class. So we are going to continue from other quantities that we have. So which is this. So let's continue with others. So the next thing I'm going to talk about, in as much as some of you've done the assignment, but I still need to carry it on here so that if you have any error, you correct it yourself. So the next one we're going to talk about is what we call those of them with the unit joules. Unit joules. So we the one that have the unit joule. Don't worry. Okay, now let's have a quick recap of the one called joules. This joule called our J. Now this joule now, before I give you the alternate units of this, now the first thing I normally do is anytime you are giving if you want to get a dimension of anything, the first thing you need to do is look at the parameter. So I want to get the alternate unit for this. An alternate unit of this now, I'll look for what quantity has joules. I remember it is work. And I remember that work is given as well. The formula is force times distance. Force times distance. And in physics, force is given as F times distance is given as S. I saw some people writing distance. No, please, distance is S for this thing now. Now, the SI unit of force is Newton. You write Newton. And the SI unit of distance is what you call meter. So this is going to be what now? Newton meter. So the alternate unit for joules, another unit for joule is what you call what now? Newton meter. But that's not all, because by the time you are writing out your units now, or by the time you're deriving your units now, make sure you derive it to the extent you get a basic unit of that quantity. So let's get the basic unit of this quantity. And how do I get the basic unit of this quantity? I'll continue breaking down this formula further into the following. I'll just say equals. Now, what is the formula for force? Okay, now let me continue from here. I'll remember that I have it as work is equals force times distance. But I'll remember that force is equals ma, that is mass times acceleration. Mass times acceleration. So which is m times a. Now, since I was able to remember that, I can easily say that work is equals m times a times s, where m simply means mass. You know that already. M is your mass. I'm writing it down so that you easily remember. Your a simply means your acceleration, and your s also means what you call your distance. Your distance, that's the meaning of your s. Now, with this now, let me see if I can get my basic unit using this one. Let me see if I can get my basic unit using this formula. Now, the unit of mass is kilogram. I write kilogram times the unit of acceleration is what now? meter per second squared. Meter per second squared. I am using minus here because I'm not using over. If I'm using slash, I won't put minus here. Please be careful. I normally see students whenever they want to write this and they will write something like kilogram per meter squared. You are not serious. Someone like me, if you meet me in an exam, especially in work, if you have something like this, you are wrong because this per and this over and this minus have cancelled each other. Per and so is per. You've cancelled it, so you don't have per already. So what you have is kilogram meter second squared, which is wrong. So it's either you put your slash this way or you put your minus. Choose one, don't choose both. So let's proceed. So I'll just say times the unit of distance is what you call what now? Meter. By the time you combine this in together, I'll just say kilogram times meter. I have meter here and I also have meter here. So meter times meter will give me what you call meter squared times second what squared. So this is going to be kilogram meter squared. Because of this minus, I'll call it first per second squared. So it now you will now see that Joe has units of Newton meter, and it also have a basic unit of what now? Kilogram meter squared per second squared. So this is the alternate unit for, or the basic unit for what now? For joules. Now this is your basic unit now, can help you get your dimension. And what is going to be your dimension? As usual now, any unit that has kilogram will go with what you call capital M, remember? Any unit with meter will go with what you call capital L. You put your squared. And any unit that goes with second will have capital T. You put your minus 2. This is your dimension. So if you understand this dimension, the next class I'm going to talk about is, for those of you getting ready for work, I think I'm going to explain dimension analysis because of late, they do ask questions under dimension analysis. And dimension analysis is what we did in year 1, but they just brought it back to secondary school work. I don't even know why, the reasons, whether they want you guys to be failing them more. So let's proceed. Now, I've already explained that of work now. I've explained that of joules. Now, since I've done that now, I'll go down to what we call that of the columns. Columns, units, columns. So we have columns. Yes, column. The unit that I will call column, letter C. Now, this unit that we'll call column now, what unit or what quantity has this unit? The only quantity that has this unit is what you call electric charge, Q. And this Q means what you call electric charge. Electric what? Electric charge. The SI unit of electric charge is what you call coulomb. And since this coulomb now what is the alternate unit for this coulomb? The alternate unit for this coulomb. The alternate unit for this coulomb. Now the alternate unit or the basic unit. Okay, let me just say alternate unit for this coulomb. Coulomb. Let me put this in. This is capital. Oh, sorry. Let me. So capital C. Let me put it here. So what is the alternate unit of this now? Now, before I get my alternate unit, remember, let me show how I get my alternate unit. I don't know the alternate unit. I will get the alternate unit using the formula. You remember that your charge, the formula for charge is what? Is equal to what? IT. I know you must remember that in your chemistry. You did electrolysis. That's where you were taught that. So your charge is given as what you call IT. So I, the unit of I is what you call ampere, and the unit of time is what you call seconds. So the alternate unit of coulomb will be what now? Ampere dot what? Seconds. Ampere seconds. So the alternate unit of coulomb is ampere seconds. And the dimension will be what now? Let's look at the dimension. The dimension will be what now? The dimension. So okay, I have it as ampere seconds. The dimension is going to be what now? Capital I and capital T. But I think you write T first before you write your what? Your I. Remember the formula, the format that I told you. The format is M first, L second, T third, before any other thing you are writing, before any other thing, theta and so on. Remember? So that's why I said I have I and T. So I have to write my T first before my I. That is the way I prefer arranging the work so that it will look better. So that is for columns. Now, since we are done with columns now, the next parameter or the next quantity I'm going to talk about is what you call volts. The next one I'm going to talk about is what you call the volts. So for the volts, for the next one, that the next unit I'm going to talk about is the units of what? Unit called volt represented with V or capital V. So that's the next unit I'm going to talk about. So that's the unit I'm going to talk about. So for the volt, what do you have under the volt? Now you remember that what parameter or what quantity has the unit of volt? One of the quantity, we have a lot of them, but I'm only going to mention one. One of the quantity that has this unit called volt is what you call potential difference, or you call them PD. You call it PD, potential difference. Now, potential difference is what you guys normally call voltage. Most times, AKA. Okay, let me just put it AKA. This is what you guys call voltage. That's what you guys call voltage, aka voltage. So potential difference. Potential difference is always written as PD, P dot D. Now, this potential difference, what is the formula for this potential difference now? The formula for this potential difference is going to be what now? Work. The formula is work over what? Over charge. Over charge. Okay, let me put it this way. Work over charge is the formula for potential difference. Now, since you have it as work over charge, normally you've already know that the unit of potential difference is volt. You know that already. But we are trying to see if we can get the alternate unit apart from this volt. You've known volt. I want to get another unit apart from volt. And the another unit I can get from this apart from volt is what now? Since I know that the formula is work over charge, the unit for work is joules, and the unit of charge is what? Coulombs. So you now see that another unit of volt is going to be what? Joules per coulombs, or what again now? Or what again? Now let's continue. For joules, when we did that of joules, if you may recall, when we did that of joules, you remember that I told you that another unit for joule is Newton meter. Yes, I say something like another unit for joules is Newton meter. So if I know that another unit of joule is Newton meter, you now see that another unit you're going to have is what? Newton meter per coulombs. That's another unit you're going to have here, Newton meter per coulombs. And you can also remember that I also told you that another unit of joules is what? Kilogram. Kilogram what? Kilogram meter squared. Um, is it per second square? Yes. Kilogram meter squared per second squared. Is it? Yes, I'm correct. So I think another unit I also told you is what you call the kilogram meter squared per second squared. That's the next unit I told you. So since you've already know that now, you can now see that another unit for volt is going to be what now? Kilogram meter squared per second squared per coulombs per coulombs. That's another unit you're going to have. This is another unit that we're going to have. Let me explain this one that I did last, because I don't know if you guys are going to understand what I did there. Let me explain it. For, you know that I told you for work that we have now, for work is the same thing as joules. Now work has the following units. It has joules, which is the same thing as what? It has a Newton meter. It also have what you call what now? Kilogram meter squared per second squared. This is for work. Now for the one on below it, the one below, which is charge. For charge has what you call the only unit of what? Coulombs. So what I was doing actually was that I was taking it one after the other. For the first one, I did joules per coulombs. Joules per coulombs. Like I picked only these two. That's the first one. For the second one, I did Newton meter per coulombs. I did Newton meter per coulombs, because since it's still work has one, two, three. That is one, two, three, and charge only have one. So I did the first one as joule per coulomb, this first one. Second one, Newton meter per coulomb, the second one. Then the third one is going to be what now? Kilogram meter squared per second squared per coulombs. But let me explain this one properly here. What I'm going to do is that um, the third one is going to be what now? Kilogram meter squared second squared all over what? All over our charge. But since it's all over charge, let me write this properly. Let me write this in very well so that you understand how I did it. Now, what I will do is I'll write kilogram meter squared, kilogram meter squared. This pair is the same thing as saying times. This pair is the same thing as 1 over second squared. 1 over, this pair is 1 over. I'll now write second squared. This line is divided. I'll write divided. Divided by what now? Divided by c. divided by coulombs, divided by coulombs that we have. Is that coulombs? Joule per coulombs. Okay. But I think this column that I'll be busy shouting coulombs, coulombs, coulombs. Coulombs have other units now. You guys didn't even record me of the next unit it has. Please. Okay, so what we're going to do is that since I'm writing the last one, I've written the first one, I've written the second one. Now the third one, this third one has a basic unit in it. So I'll make sure that this the charge or the columns I'm going to write under here, we have a basic unit as well. Column is not a basic unit, and the basic unit of column is ampere seconds. The basic unit of column is what? Ampere seconds. That's the basic unit. So for this now, what I'm going to have here is I'm going to have for the third one, for this third one, I'm going to have kilogram meter squared. No, 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 off your mic, please. Off, off. So I'm going to have kilogram meter squared times this per second. This per is 1 over. I'll write 1 over second squared. 1 over second squared. Now, because I'm going to use divided, like I'm going to divide, please, this is what I'm doing here. This is what I've written kilogram meter squared times per. This is 1 over second squared. That is for this per second. This is divided. This columns is ampere seconds in terms of basic units. So I will write ampere seconds. Ampere seconds. I'll write ampere second. I think let me get to a new page so that should I get okay, let me manage here first. I think I can write it here. So what I'm going to have here is this. I'm going to have kilogram meter squared times 1 over second squared divided by what you call what now? Ampere seconds. Ampere second because of columns. And this is the same thing as over 1. This is the same thing as over 1. So this is the same thing as saying kilogram meter squared over 1 times 1 over second squared times whenever you remove this division sign and put multiplication sign, this is going to invert normally now. So it's going to be 1 over what now? A seconds. That is 1 over a sec. So if you combine this in together, I'm going to have kilogram meter squared all over what you call second squared times second will give you second cube, and this is your ampere. You write your ampere this way. So this is what we are going to have. Let's take it to the new page. Let's take it to our new page. So for our vote, we've already obtained that from our vote, from what we have last or from what we did now. We have it that we have the following. We have our vote to be what? Another alternate formula is joule per coulombs. Another one is what? Newton meter per coulombs. And the last one is going to be what now? Kilogram meter squared per second squared. Okay, that's the last one that I'm doing right now. That last one, I think I need to explain it again so that some of you will not be confused later on when you're watching the video. So let me repeat that last one again here. That last one is gotten from what was I think work over charge, and work is kilogram meter squared per second squared all over, and our charge is coulomb. Our charge, which is in coulombs, is the same thing as ampere seconds. That is our charge. Our charge Q has a unit of coulombs, which is something as ampere seconds. Ampere seconds. This is the unit. So let me explain that last one again. So I need to explain this again, how I got what I did, so that there won't be much question later when you are watching it. So what I'm going to do is, what I did was I did kilogram meter squared. Now because of this pair, I'll just say times 1 over second squared. Now after this pair, now I have divide, I will say divided by what again now? Ampere second. I'll write ampere second over 1. I'll just put over 1 to make it balanced. So I'll just say kilogram meter squared over 1 times 1 over second squared. Now I will remove this divide and put times 1 over A seconds. So if I combine everything, I'll have kilogram times meter squared times 1 will give me kilogram meter squared all over 1 times second squared. Then second squared times second will give me what you call second cube. It's now 3. Second squared times second will give me, according to the law of indices, I will add the powers of the second. Like second is 2 and this one is 1. So 2 plus 1 will give me second cube. Then I only have ampere here. I will just put times A. This dot is times A, which is for ampere. So the final unit you're going to have as the basic unit, the final unit you're going to have for this volt is equal to what am I going to have? Kilogram meter squared. I have kilogram meter squared. Because these two are below, if you take them up, their power will change to minus. So this one is plus 3. Coming over up top of this, it becomes minus 3. This A is plus 1, invisible 1. If it comes up, it becomes minus 1. Please take note of that. So what I'm going to do here is that after writing kilogram meter squared, if I want to write this second cube, I'll write it as sec minus 3 because I am taking it up. I'm no longer keeping it below. So if I'm taking it up, I'll change it to minus 3. Likewise, this ampere. If I'm taking this ampere on top, I'll change it to what you call minus. So I'll just say A minus 1. So minus 1. Remember, it has invisible power of 1. Now, if I want to write the dimension of this, what is going to be the dimension now? As usual now, this is going to be capital M as usual. This is going to be capital L for meter. The meter is going to be capital L. Then second is going to be capital T. I'll put my minus 3. Then ampere is a unit now. And ampere is going to be what now? Capital I minus 1. So this is going to be the dimension for what you call volt. Now, if you have gotten this your dimension of volt, other people that has other quantity that has the same units as this and dimension as this include the following. That they include: number one, the quantities that fall under this category include the following. One, we have a potential difference PD. I've mentioned that already. The number two is what you call electromotive force, known as EMF. Electromotive force. Electromotive force, EMF. Then another one that falls under this category is what you call, number three, is what you call the electric potential. Electric potential. Then another one that falls under this category is electric field intensity. Electric field intensity. This is the one that falls under this category. So these four falls under this category. Although electric field intensity is quite different too. Please, I would like you to take your time. Electric field intensity is quite different because electric field intensity is given as your force over charge. The SI unit or the dimension is quite different from what I've mentioned. So force over charge, you can still get this one, but it's supposed to fall under this. Is the SI unit is not the same thing with others. So you can take it off, or you can still get the SI unit and the dimension for it. So that's it. Now, since I've gotten this one, I've gotten that of my volt. Let's take note of this. The next thing I'm going to talk about is let me talk of that of what you call resistance. For the one of resistance, let's talk about the one of resistance. For the one of resistance, what do I have under resistance now? Now, for resistance, the SI unit of anything that falls under resistance, that is, we have the units. We have the one called the unit. The unit is ohms. The one that has ohms. Capital O, ohms now. Ohm had the same thing as what you call the SI unit. Because normally here, how do you get this now? It is called resistance. And resistance has what is the formula for resistance now? The resistance has a formula of what you call V over I. And the SI unit of V is volt. And the SI unit of I is what you call ampere. V over I. That's what we have. And since we have this to be V over I now, This ohm has an alternate unit of what you call V over A. It has an alternate unit of V over A. It also have another unit of what? You know now, V is voltage. We've done that of V. You can remember there was a time I told you that V is giving us J over C. That is, voltage has a unit of J over C, joules per coulombs. So by the time you combine it now, you will now see that for our volts, for this now, let me have it here. Volt is the same thing as joules per coulombs. So if you are to write this of that of the ohms, you are going to have joules per coulombs for V all over A for current. That is all over A for current. I've written that of V all over A for current. So by the time you combine it together, I'm going to have it as joule over coulombs divided by ampere over 1. So which is the same thing as joule per coulombs times 1 over what? Ampere. So this is something as what you call joule per coulombs ampere. Joules per coulombs ampere. So that is another unit that we have here. Joule per coulombs ampere. That's another unit that we have here. So, but because of my time and other factors now, I won't have time to be deriving those things now. The next thing I need to talk about is, let me go straight to getting the basic unit. Let me go straight to getting the basic unit. Because if I get the basic unit, automatically I'm going to get the dimension. We've done this in again, so I won't have to be taking my time to derive all these things again. So going over to that now, remember that ohms is giving us voltage, volt over current, and one of the basic units of voltage or potential difference is what? Let's check again. What's the basic unit? The basic unit. This is the basic unit. So the basic unit of voltage is kilogram meter squared per second cube per ampere. Yes, I've gotten that. That is the basic unit, that the one I did last. The one we did last. So since we know that this is the basic unit of voltage, we now say all over what is the unit of current. The unit of current is what we call ampere. So if you solve this improperly, I'm going to have it as kilogram meter squared times dot dot. This dot means time, times what we call 1 over second cube. Minus is 1 over second cube times, okay, let me put times here, times this minus 3 remain 1 over ampere divided, because of this line I'll put divided by what? Ampere over 1. So I'll put this is over 1. So this is going to be kilogram meter squared times 1 over second cube times 1 over ampere. Normally now, if you remove this division sign, I'll say times 1 over what? Ampere. So this is going to be what's going to be my final. I'm going to have it as what you call kilogram meter squared times, okay, let me put it here. So I'm going to have it as what you call kilogram meter squared times, or sorry, not times. So let me multiply out this whole thing. If I multiply it out, I'm going to have it as kilogram meter squared. Then second cube, I'll just say per second cube per minus 3 now. Per, because I'm taking it up. Then this a times a will give you a squared. So it's going to be per squared. So this a times a is squared. If I take it up, it's going to be minus. So the dimension is going to be what now? M L squared T minus 3A minus 2. That's the dimension of what? Resistance. That's the dimension of resistance. So automatically, we've gotten the dimension of the resistance as what you call ML squared T minus 3A minus 2. That's the dimension of what? Dimension of resistance. So I'm sure that every other quantity that you've come across is not going to be a big challenge, or it's not going to be a challenge. I believe that you can handle them. But I think some of you were having challenge in capacitance. I don't know if you guys were having capacitor, but I'll quickly look at that capacitance as well. And let me comment that capacitance. So for capacitance, what are we having under capacitance now? Capacitance is giving us capacitance C is giving us what now? Q over V. That's what we have under capacitance. I think yes, that's Q over V. So what do you have in common here? What do you have in common here? Capacitance is given as Q over V, and under capacitance, the SI unit of capacitance is what? Farad. Therefore, the unit is going to be what you call farad. It falls under the category of the farad. So, what are the alternate units of farad apart from that farad? Are the alternate units? Alternate units for the farad. Okay, so the alternate unit is going to be what? What and what? So let's see if we can get the alternate units. So I'm going to skip the process of getting all that other units now and go over to their basic unit, because you can take your time and do all those ones again. So let's quickly go over to the basic unit of this now. And the basic unit of charge is giving us what? The basic unit of charge is giving us what now? I and T. And the basic units of voltage, as usual, let me show you where we did it before. So the basic unit of voltage is giving us what now? Kilogram meter squared is giving us what? Kilogram meter squared per second cube per ampere. That is what we have here, and I've done it before, so I don't need to repeat them again. I just want to be showing you guys what it means. So we have it this way. So since we have this now, okay, this is formula and not even the unit too. This is just a formula. I'm combining two things together. Imagine combining two things together, because this is IT over V. So this is not the unit. The unit of current is what you call ampere. I'll write ampere times. The unit of time is what? Seconds. I'll write seconds. So let's see if we can evaluate this now. Let's see what you can do. I'll just say ampere times seconds. Yes. Then what next are we combining here? Do we have anything we're combining here? Do we have anything we cancel? Do we have anything we're going to combine? Okay. Do we have anything? Meter squared, second cube. So what do we do about this now? Well, mathematically, we know what to do in terms of law of indices. In fact, let me do this way. According to the law of indices now, um, because I want to follow the order of MLT this thing, I'm going to write the first one. I'm going to write the first one, which is kilogram. I'm going to write the first one, which is kilogram. I'll write it as per kilogram. I'll write it as per kilogram. Or let me not write it the first one. Let me follow the one you normally understand, so that you won't get confused when you're looking at it. Let me follow it this way it is here. I have it as ampere times seconds. So let me just follow this way. I'll just say ampere seconds divided is this line that we have here. Divided by what you call it now? Kilogram. Uh-huh. Divided by what you call kilogram times meter squared times 1 over second cube times 1 over A. So this is over 1 over 1. So what am I going to have? I will just say ampere times second. This divide is going to be times what you call what now? 1 over kilogram. 1 over kilogram times 1 over meter squared, because this is 1, this is 1. So I'm inverting all of them. After the divisions, I'll be inverting everything that I have here. So I'll just say times second cube over 1 times ampere over 1. So that is what I'm going to have. So I'll combine everything now. I'll combine everything here now. So by the time I combine everything here now, what am I going to have here? I'm going to have the following. I'll have the following here now. Let me look for all the things that I have here now. Let's look for, okay, I have another A here. A, combine A. I'm going to have it as what? A squared. I'll have it as A squared. Second times second. Second times the second cube is going to give you what you call second raised to the power of 4. I think that there's no other thing here. All over what you call kilogram times meter squared. I have kilogram meter squared. So if I'm to write it by the MLT structure, what do I have here? Okay, let me just write it properly first before I talk about the MLT structure. I have A squared times second raised to the power of 4 times, because this kilogram is down, if it comes up, it becomes what now? Kilogram minus 1 times comes up is going, it becomes what you call it now, um per meter squared, like meter raised to power minus 2 is going to be a minus 2. So that's what we have here now. Now the next thing I'm going to do is, please off your mic, off your mic. So the next thing off your mic. So the next thing I'm going to do is, what am I going to do next now? I can still rearrange this thing to follow the MLT structure, because if I go by this now, the SI, the dimension of this one is I, the dimension of this one is going to be t raised to the power 4, the dimension of this one is going to be m raised to the power minus 1, the dimension of this one is going to be l raised to the power minus 2. But I arrange it by MLT structure, it's going to be what now? M raised to the power minus 1, L raised to the power minus 2, t raised to the power 4, and I raised to the power what? What do you have as your I? What is, okay, I is going to be squared. Okay, I squared. So it's going to be I raised to the power 2. That is I squared. So the dimension for this capacitance is given as m raised to the power minus 1, L raised to the power minus 2, t raised to the power 4, I raised to the power what? 2. I guess these ones that I'm doing last, maybe it can stress some of you. So what I would advise you to do is you watch this video and over and over and over again. Please just take your time and watch it so that you understand all this that I'm saying, because I know I said a lot of things and it might be a bit confusing for some of you. So please just take your time. I knew that when I was deriving all those things, I knew that I don't enter some technical or some challenging part of physics which some of you may not like. So the next thing you are going to do for me is this now. I'm not going to stress you guys much. I've done a lot of them. I've done resistance. I've done some of them. So other things I'm going to drop with you guys is I will just drop a table. I will just create a table and drop the dimensions of others with their formulas. You study them as well to see if you can understand how they did it. So when you study them, the task you are going to have for this physics is that by the time you study them and you discover that there is one of them, one of the quantities you do not understand how they did the dimension, or how I did the dimension, and how I obtained the dimension, please call my attention. Call my attention in my next class, which is by Monday. So when you call my attention, and in fact drop it in the group before that time, so that we revisit that together before any other new class. Because I told you before that what we'll be doing right now is, after our last class, you watch the video before we start our new class. You can ask your question for the old one before we start our new class, so that everything become fresh in our memory. So other ones include, we have something like inductance, we have something like magnetic flux, electric current, impulse, moments of a force, and so on, refractive index, so many of them that we did mention. So if I start explaining or start mentioning all of them, you know that we'll be in mention, and we are going to be in dimension for like 1 week, so which we don't really have. So this is going to be the end of dimension. Any other thing I'm going to talk about next time is going to be a revision part of it. So without wasting much of our time, because we are being warned, I think I'm going to take some of your questions now, if you do have questions, for those of you.